Hi, good morning. My name is Alan Lemus. I'm going to be your network designer. And I know we have our IT technician, Scott. So I know our company, World Construction, has been doing so much lately. We've been building skyscrapers from city to city, from town to town, and I hope to one day globally expand, right? That's the plan here. So today I want to modernize our network, right, with to implement SDN and SD-WAN. So what is SDN? It's a software-defined networking, and the other one is software-defined wide area networking. So it's just digitalized networking. It makes it a lot easier. We would eventually not use equipment more efficiently. So this brings us to have more cost savings, right? Our networks more has will have more agility, will be more secure. It's cloud ready and provides observability for Scott, our IT technician. Okay. So what's underneath our infrastructure? So is there anything wrong with our infrastructure, our current infrastructure? No. So what's under the hood? We have switches, routers, servers, that all work great together. It's scalable, it's secure, and it can easily be deployed as a cloud-ready network. And that's kind of why I'm here today. Okay, so our current infrastructure, right? Our equipment, routers, as I mentioned, switches, firewalls, wireless access points, local servers, and wide area network services, right? Connectivity, we have a combination of fiber, cable, broadband, long-term evolution, which is kind of cellular service, like our mobile devices and our laptops. We have internet VPNs, virtual private networks, secured data that's traversing over the internet that's encrypted, and MPLS, which stands for multi-protocol label switching, which is a fast way to guide computer data across a large network. Instead of reading a data packet's full address at every single stop, the network stops at a short label on it at the entrance. Intermediate routers just look at the simple label to rush the data smoothly along a pre-planned route, right? And we have our primary business networks across multiple locations, right? We have the field operations, finance and administration, logistics and personnel, project engineering, training and compliance. So those are our five branches. Okay, so the network works, but growth has made the architecture increasingly difficult and expensive to operate. So yeah, growth has networking limitations, but there's some flaws within our current infrastructure, unfortunately. Of course, there's rising costs. It's expensive for these MPLS circuits, hardware maintenance, and administrative overhead. There's performance bottlenecks. Peak traffic can overwhelm individual wide area network connections. And we have increasing complexity. Different providers, routers, firewalls, configurations, and locations must be managed separately. So we have, for example, we have Scott out there, staying in communication with Spectrum, Verizon, and AT&T businesses for specific branches, right? So the downtime risk, there's also another flaw here. Downtime risk, a failed primary connection can disrupt business operations until traffic is manually directed or backup connectivity activates. We have limited scalability, right? Opening a new construction office or project site requires additional circuits, hardware and configuration, and IT labor, which means we might need to hire more Scots, but that shouldn't be the case here, not as of right now. So the problem is how road construction manages connectivity and not necessarily our bandwidth, right? It's essentially just a fragmented wide area network that we have here on hand. So we must make the jump, right? From configuring devices to managing the network, right? So our traditional networking, which IT configures individual devices. So our administrator goes out there, Scott, and checks the switch, checks the other switch, checks a router, checks the firewall, checks a branch router, and he may be going from one department to another and back and forth. By us making this jump, software-defined networking, right? We're gonna have a software-defined controller, which is all digitized, and our administrator Scott will just be controlling that. And what that does, it pretty much controls the network, and it's secure as well. and there's automation involved. So there's templates that are going to be involved to deploy any type of measurement that needs to be done to our entire road construction network. Um, so so let's so what is software defined networking? Well, IT defines what the network should do, right? And software centrally applies those policies, and we'll go over policies later on. So SDN is typically one or many. In this case, we may start with one software-based controller or APIs, which are application programming interfaces or apps in which communicate with the underlying infrastructure and direct network traffic, as opposed to relying exclusively on individually controlled hardware devices. So this is going to be a software device. So if we look at the field operations, right? It relies heavily on LTE, right, as its primary network transport due to the mobility and remote nature of its operations, right? And but if we look at another branch of ours, the training and compliance department, it depends on cable broadband connectivity to access centralized resources hosted on the organization's file media servers. So each connection has different characteristics. So for example, let's think of a scenario. Um, or a Microsoft Teams meeting might use the connection with the lowest latency and packet loss, while a large software download can use a less expensive broadband connection. It's all about network flow or application flow that we're able to manipulate with SD-WAN, or I mean in this case SDN, right? So let's go to SD-WAN. Our current infrastructure, we see we rely on the internet, MPLS, and DSL, internet service provider modems, firewall switches, and that's one of our branches, right? That it relies on. That's our branch I'm describing here. All this infrastructure that it relies on. That's a lot of equipment there. Eventually, some equipment might be phased out, which is good. We could retire some equipment. So what is the SD-WAN edge device? Well, it could be at every location, and it's a cloud controller layer that's above everything else. So eventually, the firewall and the a layer three switch can be consolidated right into one. Okay. Uh, so so making this up, so it's gonna make this operation a very economic one. So there's also that transition of SD-WAN edge that has options, right? You could use fiber, cable, MPLS, LTE, based on the type of branch that we're configuring at the time. Okay. So yeah, modernize. So yeah, there's going to be no retirement or disposing of current equipment as of now, right? Everything just will stay as is. So we're not replacing our current switches, access points, servers, VLANs, fiber, broadband, everything remains the same. So you can remain seated there at your desk. So workstations for the most part will stay the same. Okay. But eventually, somewhere down the line, we could eventually get rid of them because, as I said, switches and firewalls can be consolidated into one, and then we could possibly sell that equipment, right? So therefore, our entire enterprise personnel will, yeah, like I said, will be it'll just be a digital transformation as of now. So yeah, so for the vendor of choice, I went with Cisco. Cisco Catalyst software defined wide area network, right? It's going to be the primary enterprise software defined wide area network solution. So our current existing architecture resembles a traditional Cisco style enterprise environment with layer 2, layer 3 switching, branch router, VLANs, and conventional wide area network infrastructure, which will make migration towards the SD-WAN ecosystem Cisco easier to prepare prior to launch, right? So let's look at the our catalyst, right? It separates the architecture into management, control, orchestration, and data plane functions, right? So that's going to be all part of the control plane. It's going to be a centralized orchestration, policy, and templates. The software-defined wide area network controls are going to be doing the routing and policy distribution. The Cisco Catalyst Center, when it's pretty much the network management, assurance, and analytics, right? And there's going to be more involved with that as well. So the proposed technology stack, again, is going to be the Cisco Catalyst software-defined wide area network for the wide area network, and then Campus SDN will be for the our branches, right? It's going to use a single policy-based fabric to handle user onboarding, network segmentation, and zero trust security from edge to cloud. And then let's go over to the identity and segmentation. We'll use the Cisco Identity Services Engine (ISE) for the cloud wide area network. We're going to use Microsoft Azure Virtual Wide Area Network. It's a cloud-based networking service that brings together branch connections, remote users, private circuits, and security into a single operation interface. It uses a global hub and spoke model managed by Microsoft to simplify large-scale networking routing. Security. It's going to be a Cisco Secure Access. It's going to be integrated into the SD-WAN, right? It supports ISC, which is Identity Service Engine integration for identity-aware security and zero trust access, while software-defined access uses Catalyst Center and ISC for automation, segmentation, and policy enforcement. So our road construction becomes cloud ready. Instead of our branch communicating with our headquarters, then our headquarters to the internet, like our internet service provider, then to the cloud, we have Azure Virtual Wide Area Network, which supports branch connectivity, site-to-site VPN, remote user VPN, express route private connectivity, routing, Azure, firewall, encryption, SD-WAN, partner integration through a hub and spoke architecture. These are digital transformations and don't rely on much on a lot of hardware. Okay, so now Rogue's Construction's branches no longer must be designed around the location of the corporate data center. All right. So why does SD-WAN matters? Well, the network chooses the best path due to the application aware routing. Right. All this is possible because of networking policies. For example, if some of our departments um, deals with voice and video, the preferred path will be the lowest latency connection. The backup will be LTE or 5G. And for engineering, CAD cloud traffic, um, the preferred path will be fiber, backup, and PLS. Um, and then we have critical business apps, SLA compliant path, service level agreement path, and then the backup will be an automatic failover, right? So what are SLAs? Service level agreements. Well, they define the performance requirements such as latency, jitter, packet loss, and availability that a network path must meet for a specific application. SD-WAN continuously monitors these metrics and can dynamically select or switch traffic to the path that best satisfies the application's SLA requirements, helping maintain reliable and consistent application performance. And this is going to be the roadmap, right? It's going to be a change within 9 to 12 months. Phase one, assessment design. We're just going to go over designing, put out the security policies, the bandwidth, service levels agreements, and business critical systems. Phase two, SDN and SD-WAN foundation, deploy management control infrastructure, establish security policies, and create segmentation model, configure cloud integration. Phase three, we're going to do the pilot, months 3 and 4, pilot training and compliance department, or another lower risk branch. We'll start from there. Phase four, we'll go on from to each branch, it's a control branch migration, months 5 to 7. Okay. Phase five, the critical system migration, months 7 to 9. That's the finance and administration department. And then phase six optimization. It's gonna be months 9 to 12. Evaluate NPS utilization, remove unnecessary circuits, tune application policies, implement additional automation, and evaluate SASE cloud security. Okay. So the transition without disruption operations. There's a risk, there's a configurations, there's going to be a service disruption. So with SD-WAN SDN, we could pilot deployment, standardized templates, and stage rollout. Employer resistance, there's going to be a slow adoption, training, communication, and hands-on support. Um, Security misconfiguration, the business impact, unauthorized access or exposure. We have zero trust, network segmentation, and policy testing with SDN. So we're going to build a network for the next skyscraper, right? Road construction no longer needs to build its network around individual locations. The network should follow the business wherever the next project occurs. Rogue wins a contract and establishes a temporary project office. Instead of IT spending days manually building VPNs, routes, firewall policy, quality of service, etc., the organization should ship a pre-configured SD-WAN appliance to the project location, which is pretty cool because we kind of there we could implement some type of segmentation at first, right? And this is going to be our final architecture. Feel free to take a look at it. And so the road construction today versus tomorrow. So I know we had device by device configuration. Now we have central policy, static routing decision. We have application aware routing. The list goes on, but at the end of the day, it's all very secure. And I want to say thank you for my presentation, and I hope things improve for us all in the future, as well as for Scott. And we could just keep Scott on board. No need to hire another Scott because that will be even more costly for our enterprise and our organization.